A very good morning, respected teachers, my dear friends, and my fellow juniors. Today, Adesh Sada from semester 5 is going to give you a talk on holography. Denis Gabo, who is also known as father of holography, was born in Budapest, Hungary. He was a Hungarian-British electrical engineer and physicist, and one of the notable works is for inventing holography, for which he also received Nobel Prize in Physics in the year 1971. Moving forward, what is holography? Originally, it originates from Greek word holos, which means whole, and graphy meaning the writing. It thus means a complete recording. This is holography is a technique of recording the amplitude and the phase of the light wave from different parts of the three-dimensional object, for which holography is also best known as a method of generating three-dimensional images. Before moving forward to the basic physical principles of holography, let us look what is a hologram. A hologram is a photographic recording of a light field. It produces a three-dimensional image of the original object when it is illuminated by a coherent light source. And the image on your screen is the first hologram, which was made by Gabo himself in the year 1948, and he used a light source that constituted of a mercury arc lamp with a narrow band green filter, which was one of the best coherent light sources before the invention of laser in the 1960s. Since holography being a two-step process, first one, which is the recording process. In this process, first, the object is illuminated by a highly monochromatic and coherent beam laser, which can be obtained by dividing the laser beam into the reference wave and object wave. As each point on the object scatters, the object wave entirely on this recording plate, as you can see here. And the other part of the laser is allowed to fall upon the plane mirror. Since this plate is exposed simultaneously to this object wave and the reference wave, what we observe here is a complicated pattern, which is also known as interference pattern, and which is also known as a developed negative, and is also known as a hologram. And this formed hologram, which we observe here, is not as distinct as the is not as distinct as the original object, but it does contains information regarding the object wave in respect of its amplitude and phase, in fringe contrast, and as well as fringe spacing. To get a clear picture of the object, we move on to the next important process, that is the reconstruction process. This is also known as the process of making a hologram. And in this process, hologram is, which was obtained in the previous step, is illuminated by a reconstruction laser beam, which was used in forming the hologram. As this hologram undergoes diffraction as this beam undergoes diffraction at the hologram, as you can see, one of the diffracted rays emerging from the hologram, when it's projected backwards, it forms a virtual image, and this virtual image can be observed by looking through the hologram as well. Whereas the other beam emerging out of the hologram forms the real image, and which can be recorded on the recording plate as well. And by moving the positions of different parts of the object can be seen in this real image. And this type of hologram is also called transmission hologram, since image can be seen by looking through it. And since then, there have been many advances in holography, such as reflection holography, volume holography, white light reflection holography, and rainbow holography, etc. Now, here is a brief comparison between holography and photography. Uh, since holography is as I have told before, holography is the 3D view of the object, but photography is only the two-dimensional view. Uh, One of the significant uh, and dominant factors of holography is that each part of the hologram contains information about the whole object, which makes it superior over the photography. As in the photography, when a part of image is distorted, uh, there is a loss of information corresponding to that particular object. Also, several images can be recorded at the same time, whereas in case of photography, a single photo film cannot help in recording several images. Without the applications, it would be useless. So here are some of the applications of holography, which includes holographic interferometry, which is a special technique also called double exposure holography, and is utilized in testing stresses, strains, and surface deformations in objects without any mechanical contact. We also have pattern recognition, which is used in industry for testing smoothness of surface, etc. And there are many other applications such as holographic microscopy, acoustic holography, and storage and re-examination of data. Here are the two crucial papers of Denis Gabo. On the right-hand side of your screen is 33. This is the 33-page paper titled Microscopy by Reconstructed Wavefronts, which was presented to the Royal Society of London by his fellow physicist Lawrence Bragg on Gabo's behalf. And in this abstract of this paper, Gabo clearly uh, states that what is and how does the holography actually works. And and on the uh, left-hand side of your screen is a normal lecture of holography by Denis Gabo. And in this paper, Gabo tells that the holography is based on the wave nature of light, since it consists of the process of interference and diffraction. And in this paper, he also considered the invention of holography, and he also credited his fellow holographic scientists and researchers who helped him in this journey and eventually made it possible for him to win the Nobel Prize in in inventing holography. And here are some of the references that I used in while making the presentation. Thank you.
Thank you, Adesh. Do the students have any questions? Prajwal sir, any questions?
Okay, sir. No questions from students. We were expecting some questions from you all. Okay, this means you have understood everything. Okay, so Adesh, it was overall a very wonderful presentation. The background and the text, the formats that you have done in the slides. But the thing is that it has got very little information. We could only see that light being refracted and then recorded on the film. And the technical aspect, much of the technical aspect were missing. If you could have put some more slides on the technical aspect of getting more deeper into the physics of holography. And apart from that, application part also, uh, I think it was okay, but you could have just picked up images from Google and then pasted it just to show us the application part. So overall, it was okay, and the construction was okay, but the content you could have elaborated it a bit to make it more clearer. Okay, So this applies to everyone who are going to present in the future. So when you put the application part, it would be best if you can give us some reference images as well, or you can put the videos also in the slide. You can do it from the YouTube. Okay, that would make it more interesting. So that's all from me. No questions from the further technical aspect. Thank you, sir.
Thank you, sir.
Sujata ma'am.
Sujata ma'am is not there.
I think she's dropped off. Yeah. Digvijay, if you have any questions.
Rudranil, sorry, Adesh. Yeah, as Prajwal sir pointed out, the content of physics was a little bit short in the slides. Anyways, Adesh, can you tell me what's the difference between interference and diffraction?
So interference and diffraction.
Yes.
So interference a pattern, so which is observed when a light field is recorded on the plate, so due to the variations of
diffraction?
phase and amplitude. So,
Okay.
whereas diffraction is when light field bends, gets bent when it comes in contact with objects. So.
Interference also happens when it comes in contact with object. What is the difference? Essential difference?
In interference, like fringe width is the fringe pattern is much clearer. So
does the object size depend? Object size?
No, sir.
The size of the object matters in diffraction.
Yes.
Anyways, okay. I had one more question. I mean, how is holography? I don't know whether you have looked at it or not. I'm also not quite familiar with this. How is holography used in microscopy? I think in one of the slides you mentioned that.
So in microscopy, sir?
Yeah. I mean, you have any idea? I'm not familiar with this actually, but just I wanted to know.
Since I have not gone much in detail, so like I've just picked some applications.
Okay. And can holography do colored imaging?
Yes, sir. It can, sir.
It can. Yeah, that's all from my side, sir. Over to you.
I think it is just like same, sir. Scanning electron microscope.
Okay.
They collect, I think, photons. They scattered. They illuminate the object by a laser, and they collect the scattered photons. I think to construct an image that happens digitally. I think.
Okay, thank you, sir.
Okay.
Yeah, Adesh, your presentation's only like 8 minutes, man. That's pretty short, especially for a topic like holography. You can go on and on for quite a bit. I want you to show me the slide where they are recording the hologram. By the way, just like what Prajwal sir said, it is actually the construction and everything is very nice, and your reference slide is wonderful. I really like it. You followed the standard formatting, which is great. But there's too little detail on physical information. Okay, so for example, you mentioned that holography, one of the advantages of holography is that you can have three-dimensional information of an object compared to a picture. right? Now here on the picture, I can see that I'm illuminating one face of the object and then recording it on the recording plate. However, I am not taking any information from the back of the object. If you look at the picture, if you look at the object, I can clearly see that we are illuminating the front side of the object, but the back side of the object is not being illuminated. So I'm not getting any information from there. So how am I getting three-dimensional information of the object through this method? What do I do with the object? Do I rotate the object?
Actually, the setup here is so like of axis arrangement. So yes, we can rotate so and get
Okay.
overall
Okay.
image.
All right. So we are rotating the object, and it's reflecting all the light rays. Okay. Is it reflect? So is the recording plate? Is it basically just writing the information on the same recording plate, or do I have to keep changing the recording plate? Because if I'm going to take information from the back of the object and I put it on the same recording plate, won't it override the data, the previous data? So just to be clear, right now I'm recording the information from the front of the object. Let's say I rotate the object to take the information of the back of the object. But that means I will just overwrite the data on the recording plate, right? Won't that cause issues? So do I use a different recording plate, or what do I do with the plate?
So since both the waves are coming from the same source, same wavefront of the laser source, it should not overlap. So.
No. If the data from the front of the object is on this recording plate, and then I rotate the object, and now I get new data, it's going to sort of record at the same area in the recording plate, right? You understand what I'm saying? It's like doing a double exposure on a photo film. It basically overwrites the previous exposure.
Yes, sir.
Okay, go to the next slide. Right, now here we have both convergence and divergence happening on the right side of the hologram. Do both of this happen, or does only one of this happen? What I'm asking is, does both the converging and diverging happen when you create a hologram, or does only one of these two happens?
So both, sir.
Both.
So virtual image also has characteristics of parallax, sir.
Okay, so what's going on with the sort of the diffraction grating that's allowing both divergence and convergence to happen?
So can you?
See, usually when you study diffraction or even lensing, either convergence is happening or divergence is happening. You don't usually get both. So what's going on over here?
Yes, sir.
Okay, so when Prajwal sir is saying that your physics information is very low, this is an example of what he means by that. Okay, I'm not trying to put you on the spot just to torment you or something. I know it's uncomfortable to have these questions, but this is what we mean by you don't have enough physics information, because these are the kind of questions that people ask, like how exactly is the information being recorded? How do we tabulate the 3D information? How do we prevent overwriting? When we recreate the information, how do we basically set it up? Okay, you've only given very, very basic points, but there needs to be more detail. Right? So this is just not just for you, but for everyone involved. The way we like to approach things is we like at least some more detail. The hologram stuff that you're talking about, it's pretty good, but there's just not enough detail for me to actually evaluate from a physical perspective. All right. So you should have put in a lot more detail, at least regarding how the setup is done, how exactly the 3D information is taken, or at least you could have talked more about the applications. Right. You could have given a slide for each application and just talked about how it works out. There are ways you could have basically made this a little bit longer and a little bit more detailed. Holography, by the way, is a very good industrial field. For those of you who don't want to go to academia, you can always go into a field where you do holography, because a lot of people use holograms. A very obvious example is like rock bands love using holograms for the stage shows. Okay, it's been being used for on like 50, 60 years now. So that's one of the things. Any like sort of theoretical or theoretical stage or even like movie industry show, they use a lot of holograms and things like that for the effects. And that's a good industrial output. Like they need experts for that. So that's a good way to get out of academia, get out of the academia path if you want. And the ideas behind holography are actually very, very important in physics. There's an entire cosmological theory called holographic principle, but that's a different thing. Okay, but aside from that, it's a good presentation, but there's just there should have been more detail, as you can see, right? Okay, Adesh.
Okay, sir.
Okay, that's it from my side. Does anybody else have any follow-up questions?